Okay, hello. This is horrible because it all leaks, doesn't it? Can you hear me okay? Is that all right? Excellent. I didn't get the brief that told me I wasn't allowed to use slides, so I apologise because you've got a few slides. My name's Mark Shayler, and I've been working in this field for about 20 years with SMEs, with Business Link. I was head of environment for Asda, Walmart, just as Walmart bought Asda, which was an interesting time. And then I've run my own business, Eco3, and I've just started another company called Tickety Boo, which is all about eco-design and waste reduction. So, what I want to talk to you about is using design to make stuff better, or using design to make better stuff. And I thought I'd start it off with a look at 6 allegedly eco-designed products, and you can give me a thumbs up or a thumbs down as to whether you think these are good things. So top left, that is a Barbie smile necklace. The lady that makes these is interested in recycling toys, so she cuts off the smiling face of Barbies and puts them into jewellery. I think this is one step removed from making a dress out of skin. However, she seems to be selling lots of them. Good or bad? Bad. Excellent, thank you. Next one, top right, my favourite. This is the granny boombox. So not content with having mobile phones that go tss, 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 tss. When you're aged and you can shop, you can now take out your hi-fi in a little shopping trolley. Now, I quite like that, but I think the market might be limited. Good or bad? Okay, and I wanted you to say good. I got you one for your birthday. Okay, middle left. This is a coat made out of wrapping paper. Now, my wife's got a policy that if it looks crap on the model, don't buy it. And I think she wouldn't buy this. So you take wrapping paper and you turn it into clothing. Good, bad? Bad, thank you. And then we've got the keyboard handbag. I don't know what that's all about, but you can now buy keyboard handbags. Do you think there's enough keyboards to go around? Bad. Yeah, excellent. And then there's the Carlsberg clip-on tulip vase. So when you've finished your Carlsberg or your Stella or whatever you drink, you clip this little thing on the top and you can put a single flower in every beer can. So good, bad? Yeah, pointless. This is not eco-design. And then there's the good old Hummer. Thirsty for adventure, not for gas. The small print, 20 miles a gallon. Please, let's just not make them in the first place. Now that's eco-design. Let's not make bad things a little bit better. Let's make astonishingly good things brilliant. That's my view. That's how we need to use design. Design is really important because once we've designed something, we've set 80% of its impact, environmental and cost. We know when we've designed this laptop, when it's going to fail. We know what its energy efficiency per hour of use will be. We pretty much know what its recovery and its recycling cost will be. Once it's designed, to get things changed and right afterwards is increasingly expensive. Design is the most important part of that process. At the moment, we've got massive drivers on cost, obviously, and I'm acutely aware as a small business owner that cash flow is king, and trying to make my working capital go further is absolutely crucial. And my argument is that good design is cheaper than bad design. And some of the figures that support that are really clear. If you mess something up and you've got to improve it or change it in production, for every £100 you spend in production getting it right, you could have done it for £10 during the development phase. Tenfold increase. Or if you'd got it right at design stage, it would have only cost you £1. So it's 100 times more expensive to put something right once you've gone into production. So we need to be really, really smart about how we use design. And not only are there financial drivers, there are also absolute environmental drivers too. If you look at, you all heard of peak oil, yeah? Everyone, peak oil, no? Come on, shake a head or a leg. Yes, everyone's heard of peak oil. No, don't be embarrassed, sir. I have a friend who hasn't heard of it as well. No, peak oil is the idea that we've got a certain amount of oil in the Earth's crust, and slowly, merrily, over the last 80 years, we've been extracting it out at faster and faster rates. Now, at some point, the speed in which it comes out will decline. We will go past peak production. Depends who you talk to. Some will say that's just happened. Others say we're 10 years away. I don't really mind when it is. It's about now. Now, what this slide shows really well, the past is on the left, that's the dark, and oil discovery is in blue at the front, oil production is in green in the middle, and oil demand, oil use is at the back in red. And in the past, we know where oil is, it's there, we don't take it out, we produce it to meet demand, or we demand it to meet production. I don't quite know how the macroeconomics work there, if I'm honest. But in the future, it looks less rosy. We can still produce at a relatively high level, even though we're not going to discover much, because we've got these reserves, okay? And we are finding more oil. We found some, I think, near Mexico last year, this year. That's about 2 weeks worth of world use we discovered, and that was a big find. So we're going to discover much less, but we can continue to produce because we've got these surpluses. But look at demand. By 2030, child born today will be 20 then. The gap between supply and demand is huge. Now, we've just hit new highs on oil prices, sorry, relative highs on oil prices last week. I think the 2-year projection is $150 a barrel. So this gap is going to determine where prices go. So we need to do more with less. We need to be smarter, and design's part of that. We've also got increasing awareness of the reduction in availability of fresh water. And I think demand for water is set to rise 50% by 2030. The availability of water is an unknown element. And I do a lot of carbon footprinting within my business. And a number of my clients and big DIY sheds are now asking me about water footprinting. How much water is used in a table? How much water is used in a square metre of laminate flooring? That kind of thing. So I did some digging, and these stats are from the Pacific Institute. Do a lot of research in this. And this month's National Geographic, if anyone's interested, has got a special on water. It's an excellent magazine, well worth reading. But this shows how many litres of water in a set unit of commodity. So beef, this is American-produced beef, which uses a lot of soya to feed it rather than grazing. 16,000 litres of water per kilogram of beef. Massive. It would be a much less for European models. A kilo of cotton, 11,000. A hamburger, every Big Mac you eat, 2,400 litres is the embedded resource. But the good news, if you drink beer, beer is only 300 litres per litre. So I've worked it out, you can drink about 12 pints of beer or have a hamburger. It's your call. I know where I'm headed, to the pub. But water scarcity and security is increasingly important. Working with shower companies, looking at how we use water within that industry is really fascinating. We determine an eco shower as one that uses 6 litres a minute or less. In Australia, they don't have any of that rubbish. 6 litres a minute is not a shower. That's an unpleasant wetting experience. So in Australia, what they do is they've invented the quench shower. And the quench shower is a proper 13 litres a minute shower. You go in, you ablute, you wash, you get the muck off you. You then press a button, and it recycles all the water back through the system again. It saves water use by 85% and energy by 82%. And at first listen, it sounds a little bit icky. But when you compare it to sitting in a bath, and I've got children and I have bath with them, I know what's in that water. It's very unpleasant. It's actually quite smart. So you don't have to live in sort of poverty or in impoverished conditions to be eco. There are smart ways around this if we use design. We all know, RAP have told us that 1/3 of what we buy goes in the bin. This is from the States. The scary figure for me in terms of food is 50% of what we grow never makes it to the retailer for aesthetic reasons or because it's gone off in the cool chain. And food security is a massive problem, will become a greater problem. And it's really important that we pack things appropriately. It isn't enough to reduce packaging. It's about making sure the product gets to us in a fit form to eat and lasts as long as possible. So a bit of polyethylene around your cucumber gives you 10 days extra fridge life. That's a good thing. Even though we don't like plastic packaging, that is a good thing. So we need to associate product and packaging as one system. It's really important. And then we've got absolute resource scarcity. This is from the New Scientist in, I think, May 2007. It looked at how many years of materials we've got left. You can't read this, so I've pulled the elements out. So if you look at rare earths, you've got 2 figures here. Indium, used in liquid crystal displays. You've got 13 years of indium left, estimate, if we consume at world average rates. If we consume at half the rate of the Americans, we've got 4 years left. Now, it's okay because we've got organic light-emitting diode televisions on the way. We're all going to be just fine. But this just shows you how little we've got of some of these raw materials. Now, obviously, as something becomes incredibly scarce, we surprisingly find new sources because the cost has risen and there's this whole supply and demand, and it's worthwhile extracting other things. But we need to be really cognizant that some crucial elements, hafnium, electronics industry, nuclear power industry, if we don't want the lights to go out in 2017, we need to have access to hafnium. And we've only got 10 years left. So we need to do, again, just do much more with less. So we can design through some of these problems. I'm not going to lecture you on climate change. Some interesting news this week. Thought that we're going to be hitting around about 3 degrees by the end of 2100. The science is in disarray. The science is actually in a corner with a D on its head at the moment. But if we hit 4 degrees, we see the Gulf Stream begin to relocate. We see the warming element within Western Europe removed. We're on the same latitude as Moscow and parts of Canada. So we could see significant cooling. It's going to make a massive difference to the way we produce food. So it's there, we mustn't ignore it. It's very important that we understand the impact of the products that we make. The impact of the products often outweighs the impact of the process. And CRC is a great piece of legislation, a great mechanism for looking at our impact, but we can ignore the biggest impact if we're not careful. We need to identify where the true impact lies. And I've got an example for you. Working again with a shower company, if you look at the stuff that's measured under CRC, their typical office and activity, assembly, warehouse, distribution, their impact's around about 3,000 tonnes CO2e a year-ish, approximate back of a fag packet calculation. If you look at what they produce, 50% of their output is gas or boiler-powered showers, 50% are independently electrically heated showers, and if you look at a year's worth of use of those products, you're looking at 667,000 tonnes, lots bigger than 3,000. By messing with the design of the electric shower, we can knock 20% of the impact off that. We can knock 10% therefore of the impact off this figure. That outstrips anything that we can do on site by becoming more energy efficient. So we need to focus on what's really important, and it isn't often the manufacturing process. And I did a conference recently for the IBC in Amsterdam, and I began to look at broadcast and the amount of carbon used in things like internet searches and in video on demand, because it's TV mark. If I want to watch something on my telly, I go straight to iPlayer or to 4OD. I don't bother with adverts. Adverts are just the thing of the past. I watch what I want when I want. Spotify is the same thing. And that was really interesting, looking at the carbon impact of that. The most efficient way of getting TV to you is by putting a mast on the hill. It isn't by everyone watching what they want to watch when they want to watch it. But I got intrigued by something called Second Life. Has anybody here played Second Life? No. Good. I can say what I like. Second Life, 2 minutes, unlikely. Second Life is a computer program that allows you to have an alternative person, to live your life, and you can do anything. You can eat, you can sleep, you can have a partner in that life. There are no ugly people in Second Life. They all look like that. I'm the guy on the right, obviously, apart from on Saturdays when I'm the lady on the left. And you live this alternative lifestyle. But to keep an average avatar alive for a year takes almost 1/2 ton of carbon. That's the same as it takes to keep a real Brazilian person alive. And what kind of ethics is involved here? There's some really serious questions we need to ask. Right, rushing on. Eco-design. I think by using design, we can massively reduce the impact. Eco-design is, I think, probably the single most effective tool we've got in terms of reducing impact. It looks at the whole life cycle, allows you to compare different strategies. We consider materials, production, transport, disposal, and it works. I've done loads of stuff, just a few examples here. Top left, 1 minute. I've got a little bit, because these guys aren't going to, they've told me, I can have some of theirs. Pasta King, worked with this company to massively reduce the carbon that they used in their packaging, and to change, move away from a polystyrene cup to a fluted cardboard cup. We got them in excess of £1 million worth of savings through all the interventions, and we got an increase in sales, and we dropped carbon use by 11,000 tonnes. Belkin, brilliant company, make electrical things, make small electrical things, put them in big boxes. Obvious solution, put them in smaller boxes. They loved it. They went for that. We did this little Bluetooth adapter, £98,000 saving, 60% increase in sales in a smaller box. Now that goes counter to what you believe. Big boxes, more advertising space. But the problem is the boxes were so big, you could only get 4 on a shelf. In the afternoon, you're buying somebody else's product. So just by getting more on a shelf, we sold more product. Brilliant. I'll just do mozzarella quickly. A company in North Wales who make mozzarella. Went to see them, looked at their process, looked at the way they use carbon, looked at the way the machines break. Thank you. And And we managed to change the packaging, drop the carbon footprint by 20%, reduce breakdowns by 75%, and save them £42,000 for one day's work. So really simple stuff pays off. Thank you.